We're going to work with one side of the equation at a time. Do not do both sides. You only do one of the sides. Okay. It is always better to look at the more complicated side. Okay. So not the easiest side. We want to go from the complicated side and break it down to the easiest side. Okay. Look for opportunities that we can factor. And do you guys remember how to factor? Difference of two squares, trinomials, all of that. Okay. So we'll try to see if we can factor. Sometimes can we add fractions? Okay. Can we square a binomial? Or can we create a monomial factor? Denominator, sorry. Monomial denominator. Okay. So anytime you see that plus or minus in the denominator, okay, always use that one, okay? And we want to make it where it's a monomial denominator, meaning we want to multiply by its conjugate. Do you guys know what conjugates are? If I had like, we always did it with radicals. If it was like 1 plus radical 2, its conjugate would be 1 minus radical 2. So if we're looking at trig functions, if we have 1 minus sine squared, what would it be? Its conjugate, 1 plus sine squared, okay? That's what that means in that sense, okay? Look for opportunities to use fundamental identities. And didn't you guys just write down the fundamental identities for on Wednesday? Yes. So you got your Pythagorean ones, you got your quotient ones, okay, reciprocal, all of those. Okay. Okay, we want to try to break down. We want to break it down to the final expression we want. Okay. So we're looking for how do we break down the left side to get to that final side, which is your right side. Okay, things like that. Sines and cosines pair up well, right? Because isn't sine squared plus cosine squared equal to what? 1. 1 minus cosine squared would equal sine squared, okay, things like that. Secants and tangents. Secants and tangents will pair up well, okay? Why? Because 1 plus tangent squared is equal to secant squared, right? So tangent squared would equal to secant squared minus 1. And then cosecant and cotangent match up well. And these are all coming from your Pythagorean identities, okay? Also, tangent, you can always take tangent to sine over cosine, right? Okay. When proceeding the guidelines, try to always convert, I can't even spell it now, convert all terms to sines and cosines, okay? Because then if they're in all sines and cosines, couldn't I take sines and cosines to tangents? Can I take sines to maybe secants? And same thing with cosines, and same thing with cotangents, okay? You could take everything from sines to cosines, other of our trig functions, couldn't we? Yeah. And then the last thing, always try something. Okay. Sometimes your attempt may lead to a dead end, but that's okay. If we lead to something, it will give us some kind of insight that we can then go being like, oh, that doesn't work. Because sometimes we have those sine squareds equal something, but it doesn't get us to like cosecant. All right. So just trying something will be like, oh, well, that's not going to work. We know that trig identity wouldn't work out, the fundamental identity, and we just go to something else. Okay. All right. So let's look at example 1. Verify that secant squared theta minus 1 divided by secant squared theta is equal to sine squared theta. Which one looks more complicated? The left side. So let's kind of break this down, and we want this side to get to sine squared theta, right? So let's start with our numerator. Secant squared minus 1. Okay, looking at your trig function, secant squared minus 1. Do we have anything with secant squared here? Huh? we know that secant squared equals 1 plus tangent squared. So if I subtract that 1 over, what would secant squared minus 1 equal? Tangent squared. So can I take my numerator and change it to tangent squared theta? Yeah. And that is, we took the Pythagorean identity, right, of 1 plus tangent squared equals secant squared. Obviously, you don't have to write this part. I'm just writing it as we talk through it. Okay. All right. Secant squared theta. Can we simplify the secant squared theta to anything? We can do 1 plus tangent squared. Yep. Or what else? Anything else? Okay. Actually, real quick, what are we trying to get to? We're trying to get to sine, right? Okay. If we're trying to get to sine here, am I going to change that back to tangent, you think? No, because we don't want to have addition or subtraction in the bottom, right? So what else can you tell me about the secant squared? It is 1 over cosine squared theta. Is that true? Yeah, because we always want to try to take everything to what? Cosines and sines, right? Because the numerator had that minus 1, we couldn't go to sine or cosine then, right? But we can now take tangent squared to something, couldn't we? What can we take tangent squared to? Tangent squared is equal to sine squared theta over cosine squared theta. Is that true? And I'm going to leave the bottom as 1 over cosine squared theta. Now, we have everything to sines and cosines, don't I? Yeah. So can this help me in anything? We have this crazy fraction. Do you guys like fractions? No, but do we know how to divide fractions? Yeah, don't we keep it, change it, and flip it? Can I do that? Yeah. So we're going to have sine squared theta over cosine squared theta times what? Cosine squared theta over 1. Now, if we multiply, what can we do here? We can cancel out cosine. So what am I left with? Sine squared theta. Is that what we wanted? Yep, and he just did it. So I would have to see all of this work from that. So if possible, we want to break everything down to sines and cosines, right? Okay. Now, obviously, with the secant squared theta minus 1, we had to go to tangent squared theta first. But with that tangent squared theta, can we then take it to sines and cosines? Yeah. Okay. All right, let's look at the second one here. Verify that 2 secant squared, I'm just going to say theta, equals 1 over 1 minus sine theta plus 1 over 1 plus sine theta. Okay. Which one's more complicated? The right side. So let's work with the right side. Okay. So we're going to work with this right side. Now, as I look at that denominator there, is there anything that equals 1 minus sine theta? What? Well, cosine squared theta would equal 1 minus sine squared theta. Is that 1 minus sine squared? No. So does that actually equal that? No. So do we have anything that equals 1 minus sine theta? No. But let me ask you, do we know how to add fractions? Yeah. How do we add fractions? Common denominator. Can I find a common denominator between 1 minus sine squared and 1 plus sine squared? Yeah, what is my common denominator? What's my common denominator here? Anyone? Wouldn't my common denominator be 1 minus sine theta times 1 plus sine theta? Yeah. Okay. So we need to change both of these to 1 minus sine and 1 plus sine. Okay. So what would I have to multiply the first fraction by to get to this common denominator? Huh? I have one minus sign on the bottom, but I need one minus sign and one plus sign. So don't I need to multiply top and bottom by one plus sign? Yeah, so I'm going to multiply the top by 1 plus the sign. And what's 1 times 1 plus the sign? 1 plus the sign. Would this simplify back to that first fraction? What's missing in the second one? 1 minus. So what's 1 times 1 minus sign? Isn't that 1 minus sign? Yeah. And if I cross those out, wouldn't I get back to the original? Now, do we have a common denominator? Yes, and if I have a common denominator, can I go ahead and add my numerators? Yeah. What's 1 plus 1? Bless you. You're welcome. 2. What's a positive sign plus a negative sign? 0. So I just have 2 over. Now, we have this 1 minus sign and the 1 plus sign. What do you think I can do with that denominator? I can FOIL it, couldn't I? Couldn't I FOIL this? And don't you guys notice that these are just conjugates of each other? So isn't that the difference of 2 squares? And if they're the difference of 2 squares, do I have to multiply the outside and inside terms? No. So I would just have to multiply the first terms and my last terms. So what's 1 times 1? 1. What's a negative sign times a positive sign? Negative sign squared. Now what do you guys notice? What do you notice about 1 minus sine squared? That is equal to cosine squared, isn't it? And isn't that your Pythagorean identity? No. We have 2 over the cosine squared theta, right? Let me ask you, okay, you don't have to write this up, but isn't this 2 over sine, isn't that the same thing as 1 time or 2 times 1 over the cosine squared? Is that the same technically? And what do you guys know about 1 over cosine squared? That is equal to secant squared. Is that what we wanted to end up with? Yes, we did. Now, I probably wouldn't have wrote this step because cosine squared is in the denominator. I would have known automatically that it's my secant squared. Okay. Verify that tangent squared theta plus 1 times the cosine squared theta minus 1 equals the negative tangent squared theta. Whew. Which one's more complicated? The left one. So let's work on that side. Now we are multiplying, so we could FOIL if we wanted to, couldn't we? But before I actually FOIL, I would see, can I simplify any one of these parentheses first into something else? Because simplifying is easier than actually FOILing, isn't it? Yeah. So tangent squared theta plus 1. Do we know if that's equal to anything? Secant squared, yeah. So that first one is actually secant squared theta, isn't it? Times. What about cosine squared theta minus 1? Huh? It is negative sine squared. Why is this one negative sine squared and not positive sine squared? Right, because in this normally we know that sine squared plus cosine squared theta equals 1, right? So if I'm looking at sine squared, I would subtract the cosine over, right? So I would have 1 minus. But what do you guys notice about that? It's cosine squared minus 1. So couldn't I factor out a negative 1, making that a negative sign? Does that make sense? Okay. So now we have secant squared theta times negative sine squared theta. We want to get somehow to tangent squared theta, right? Let me ask you, before I do anything, what do we know about tangent squared? What is tangent equal to? Is that equal to sine squared over cosine squared? Okay, so we want to make sure we can get these two sines and cosines as well, right? So what do you guys know about secant squared? This is 1 over cosine squared theta times negative sine squared theta, right? Isn't that over 1? So what is 1 over cosine squared theta times negative sine squared theta? Is that negative sine squared theta over cosine squared theta? And now what do we know about sine squared over cosine squared? It is equal to tangent squared theta, but we have the negative, so it is a negative. So is that what we wanted? Yes, it is. So we're done. Verify each identity. Go ahead and do A on your own. Which side's more complicated, the left or the right? The left. So you should be breaking down tangent x, cosecant x, and getting it equal to secant. The easiest way is to try to always break down the sines and cosines as much as possible. Okay. So what do you guys know about tangent? Tangent is equal to sine over cosine. What do we know about cosecant? 1 over sine. So now we have sine x over cosine x times 1 over sine x. So what happens when we multiply those? The sines cancel, and I'm left with 1 over cosine x. And what is 1 over cosine x? Secant x. Is that what we wanted? Yep. So you're done. All right, B, we have tangent x plus cotangent x equals secant x cosecant x. Okay. Is addition or multiplication harder? I would think addition. Why do you guys think addition is harder than multiplication in this sense? They're harder to cancel out. And also when you add cotangent and tangent, aren't they like fractions of sine and cosine? So you would have to have common denominators, all of that. So actually the addition one is actually more complicated because we can take addition to multiplication, couldn't we? Going from multiplication, breaking to addition is a lot harder going backwards, right? So let's think about tangent. What do we know about tangent? It is sine over cosine plus. What do we know about cotangent? It is the opposite, which is cosine over sine. Now, to be able to add, we need to have a common denominator. So if one denominator is cosine, one is sine, what's its common denominator? Wouldn't it be cosine x and sine x? Right? We just incorporate both of them. You guys okay with that? All right. So now, if I look at the first fraction, my first denominator is cosine, but I want to get to cosine times sine. So I need to multiply the numerator by what? sine, right? Why? Because the cosine's already there, right? We're missing the sine. So what's sine x times sine x? Sine squared. Yes. Because if I simplify the sines, right, when I get back to the original, what's missing in the second fraction? Cosine, right? So I got to multiply by cosine. So what's cosine times cosine? Cosine squared. All right. Now, do we have a common denominator? Can we go ahead and add our numerator? Yes. What is sine squared x plus cosine squared x? 1. So we have 1 over cosine x times sine x. Is everyone okay with that? Now, could we take this and break it back up into 2 separate fractions into multiplication? Yeah. Isn't this the same thing as taking 1 over cosine x times 1 over sine x? Is that the same thing? And the only reason why I separated these two is because we want to take it to secant times cosecant, right? What is 1 over cosine? Secant. So isn't that secant x? Times what's 1 over sine x? Isn't that what we wanted? Yeah. So that's the only reason why I split it. Now, could I go from here to get to my answer? Technically, yeah, because we know we have it's 1 on top of each of those, right? Any questions with that one? All right. Yeah. Yeah, hurry up. All right, verify the identity of secant x plus tangent x equals cosine x over 1 minus sine x. Which one do you think is more complicated than this one? The division one, right? The one that has the fraction in the denominator, right? Or the addition in the denominator. That's technically subtraction, but that's okay. So we want to take the cosine x over 1 minus the sine x and break it into this addition problem, right? So in both of these right now, we really have no fractions, right? I mean, they will go down into fractions, but we'll get to that in a second. So we need to kind of get rid of that subtraction in my denominator, correct? So if I want to get rid of that subtraction in my denominator, what did I have to do? Remember when we rationalized radicals? Same idea here. We're kind of going to rationalize this a little bit because we don't know what 1 minus sine is, do we? We do know what 1 minus sine squared is, right? So would I be able to multiply by its conjugate to simplify that denominator? Yeah, what is its conjugate? 1 plus sine x, right? You guys okay with that? All right. Now, looking at my numerator, cosine times 1 plus sine x. Isn't that the same thing as cosine x plus cosine x sine x? Is that the same? Yeah. Over, now how would I multiply 1 minus sine x and 1 plus sine x? How do I multiply that denominator? Can't I FOIL it? And when I FOIL it, what happens to those outside and inside terms again? Won't they cancel out? Yeah, so let's do our first term. 1 times 1, 1. And what's a negative sign times a positive sign? Negative sine squared, right? Everyone okay with that multiplying there? Now, what can you guys tell me about my denominator? It is cosine squared x, yeah. Everyone okay with that? Now, we have an addition problem in the numerator. Okay, remember when we had up here, when we had the two fractions, we would add the numerators, right? So technically, isn't this one here sine squared x plus cosine squared x over all of this? And then we were able to simplify the top. Can I go from this back to the two fractions? Could I take this and make two fractions from it? Yes. Wouldn't that be the same thing as cosine x over cosine squared x plus cosine x sine x over cosine squared x? Is that the same? Because think about it. If these have common denominators, don't we add the numerators? Leave the denominator the same? Yeah, I'm just working backwards in that sense. Now, since we have two individual fractions, can I simplify those? Yeah, what would cosine over cosine squared be? 1 over cosine. Why? Because we can take a cosine out of each of those, right? Because cosine squared means cosine times cosine. Okay. What about cosine x sine x over cosine squared x? What would that equal? Sine x over cosine x, because you can cross out one of those cosines, right? Now, from here, do we know what 1 over cosine is and what sine over cosine equals? 1 over cosine is, excuse me, thank you, secant x plus, and what's sine x over cosine x? Tangent. Is that what we wanted to equal? So again, do you guys see why from the first one I went from addition to that? Because it does get, it's more complicated to get to addition. Yeah. All right. Verify cotangent x over 1 plus cosecant x equals 1 minus sine x over sine x. You can't see it yet? Well, it's on your paper. All right, which one's more complicated? Is the addition in the denominator harder than the subtraction in the numerator? Or is it vice versa? Yeah. Also, go ahead and change cotangent. It's supposed to be cotangent squared. That was my mistake. I forgot to type that. It was supposed to be cotangent. If it was just tangent or cotangent, it wouldn't work. Just so you know. All right, cotangent x. So we're going to work with this side. This is harder when you have a addition sign in the denominator. Let's kind of just look individually first before we actually rationalize if we need to. Okay. What do we know about cotangent squared x? Do we know anything about that? That is equal to cosecant squared x minus 1. Yeah. Now, last time we went ahead and rationalized our denominator, right? But I want to check something here, okay? Look at your numerator. What do you guys notice about that numerator? What do you notice about that? What if I gave you something like this? X squared minus 1. What if I gave you x squared minus 16? 1. You could factor it. Isn't this a difference of 2 squares? Yeah. So I would try to factor that. Because I wouldn't really want to have to FOIL, would you guys? No. So always try to factor before you actually have to simplify in that sense, okay? So I'm going to go ahead and factor that. And what does secant squared x minus 1 factor 2? If you're doing difference of 2 squares. And that'd be secant x in the first term. And then we'll have plus 1 and minus 1. And then we have 1 plus secant squared x hat. So we factored. So what do you guys notice now after I factored that? I cancel something out. So what am I left with? I'm left with cosecant x minus 1. Now, is that what we wanted? No. But we're getting there, right? Because is there something you can tell me about cosecant? That is 1 over sine x, right? Minus 1. So we want to get to this 1 minus sine x over sine. Right now we have 1 over sine x minus 1. So we're getting closer, right? But what do we have here? We have fractions, right? And do we know how to subtract fractions? Do we know how to subtract fractions? Yeah, we need a common denominator. So what's the common denominator between sine x and 1? Sine x. So the first one is going to stay the same, isn't it? What's 1 over 1 going to be with something over sine? Wouldn't that be sine x over sine x? Yeah. And now, do we have our common denominator? Yeah, so now can we go ahead and subtract them? 1 minus sine x is 1 minus sine x over, what's my denominator? Is that what we wanted? Yes. So did we get there? Yes. Yeah. All right. All right, last examples here. Tangent 4 to the 4th power x equals tangent squared x secant squared x minus tangent squared x. Phew, that's a lot. Which one looks more complicated? The right side, yeah. What do you guys notice about that side? What's one thing that just stands out automatically? I see tangent squared in both of those, right? So could I factor out? Could we factor out a tangent squared as a GCF? Yeah, so I'm going to go ahead and factor. I'm going to factor that tangent squared x out. And if I take that tangent squared x out, what am I left with? Secant squared x minus 1. So we want to get to tangent to the 4th power. We already have tangent squared. We need to see what, can we convert secant squared x minus 1 to something? Yeah, what does that simplify to? Isn't that tangent squared x? So now we have tangent squared x times tangent squared x. And what's tangent squared x times tangent squared x? Tangent to the 4th power. Is that what we wanted? Yes, it is. And then the last one, cosecant to the 4th x cotangent x equals cosecant squared x times the quantity of cotangent x plus cotangent cubed x. Phew. Which one's more complicated? Just saying it seemed more complicated. I'm going to say the right side again, right? Just saying it. Looking at that, so they obviously factored out the cosecant squared x, right? But what do you guys notice inside my parenthesis? There's 2 cotangents. So could I have actually factored out a cotangent as well? So did they, when they factored that, did they factor out the greatest common factor? No. They should have factored out a cosecant squared x and how many cotangents? 1. So what would be left over if I take a cotangent out? 1 plus cotangent squared x. You guys okay with that? Now, we want to see, do we know anything about 1 plus cotangent x? It is equal to cosecant x. So now we have this cosecant squared x times the cotangent x times the cosecant squared x. So is there anything I can multiply to combine here? This is all multiplication, isn't it? So can I take what's cosecant times cosecant? Cosecant to the fourth power. Is that what we wanted? Yes. So are we done?